Hi everyone, I hope you can hear me now. I'll wait for 1 more minute and we can get started. Meanwhile, if you can hear me, just message on Slack. Thanks team, I can see your message. Cool, let's get started. So before going to lesson 2, let's quickly see what are the things we have seen in the last session. So in the last session, we had an introduction to Fastai. So in Fastai, especially we built a machine learning model, deep learning model, which is a image classifier. Okay. So in image, is it a bird or not? Is it a bird or not? We built an image classifier. So what we did is we used data block API, and then we downloaded many images. Then we cleaned a few images. Then we used vision learner to build a model, and we used fine tune and predict. So those are the things we have seen in the model building stage. And then we learned some theory about what deep learning can do now, and about top-down approach, and something about Jupyter notebooks, and about visualizing layer and those kind of things. So in today's session, what we are going to do is we are going to build a model, and then we are going to deploy. So in today's session, we'll be covering 4 different areas. One is about model, like what are the improvements we can do with model, and how to interpret model results, and how to use a model to clean some data sets, like data cleaning using model. So that's a different approach. So usually start with data cleaning and then we build a model. But here is another approach, like you build a model first, and then based on the results, we can clean the data and rebuild the model one more time. And finally, we'll be focusing more on model deployment. So we build a model, and then we can create a user interface, and then we can deploy that in HuggingFace so that we can share it with others. So these are the tasks we are going to do today. So let's get started. I hope I'll zoom a little bit. Cool. So these are the things we have seen in the last lesson. So what we did is we downloaded a few images. So I'll show it here. So currently what we are going to do is we are going to build a classifier with 2 things. One is bird and another is forest. So what we are going to do is whether our model is going to predict if something is bird or not, like bird or forest. So what we did is we downloaded 200 images of bird and then 200 images of forest. Then we resized all the images to 400 pixels, 400 by 400. That's the maximum size allowed. Okay. Then what we did is we tried to find if something failed while downloading the images. If something failed, we will delete those URL. Okay. So that's all we did. In this case, there is no failure, so it's 0. Then we created a data block API. In the data block API, this is like a common things we do with any deep learning or machine learning project. So the first step is we try to mention what's input and what's output. In our case, our input is image, and then output is categories. So one category could be forest, like you can see it here, and the other category should be bird in this case. And then get items. Now we defined what's input and output. Now we have to define how to get data files. So there is a function called get image files. Let me show that here. Get image files. So by the way, if you use question mark, you can see the source code. Like here you can see get image files, and what's it's doing is it's calling another function get files, and you just pass some path and it will list all the files recursively. So that's what it's going to do. Maybe let's give a path, and you can see in our file we have 384 images, and you can see each image one by one. Okay, so there are 384, and by the way, this is called list. Fastai built a special type like L. You can show it here. If you use type, it will tell you the data type. It should be foundation.l. So it's very similar to list, but you can see how many items there. Okay. So currently this file has 384 images, and you can see it one by one. So that's all this get image file is doing. And then after building a model, we need to know how well our model perform in unseen dataset. For that, what we are going to do is we'll be splitting our dataset into two parts, one for training and other for validation. So we use training dataset to train the model, which means the model is going to learn some patterns using the training data, and after that it will use the validation dataset to make some predictions, and we can see how well the model is performing. So currently we are setting 20% for validation. So out of 384, 80% will be training, remaining 20% will be for validation. For reproducibility, we are setting some seed. So if you use some same seed, you will get the same set of validation dataset every time. Now we have provided all the images. Now we need to know the label for each image. How to find label is, if you see this URL, we can find the label from this URL. If you see that, this is image, and then his parent is forest. So you can see forest. So you can use a function called parent label. So parent label, what it does is just split and then return the previous one. Parent label, question mark, question mark. So it just uses path object and then parent.name. So you will get forest. Okay. Then we are resizing all the images to 128. Okay. So after doing this, we are creating a data loaders. So data loaders going to combine all these things as a batch, and after that we can visualize a batch. This is the first batch with 4 elements. So first is you can see some sample like forest and bird. Okay, so this is a normal thing that we did in the last session, but now what we are going to see is different ways to represent data. For example, if you see it here, we are going to represent in 3 different ways. One is squish, pad, and crop. So this is what squish going to do. It's going to squish all the complete image, and you can see the different shapes of squish. And padding means to resize, what we are going to do is we are going to add empty 0 at around the border, so that everything will be in same size. This is another approach. This is called 0 padding. And then the next one is cropping. We are randomly resizing and cropping of the image. For example, the original image, let's say this is the original image. This is one crop, and this is another crop, and this is another crop. So we can experiment with different approaches, but in the lesson Jeremy mentioned best approach is using random resized crop and then data augmentations. So I'll talk about what is data augmentations. So if you see, data augmentation is like a technique to create many different data, augmented data from a single image. So you can see it here. From a single image, what we are doing is we are changing the shape, like rotating the image, and then adding more lights, darkness, those kind of things. So if you do that, we can create many images from a single image, so that model won't overfit to a single data, because it's going to see many different variations during model training. Okay. So this augmentations is very important. So what the best practice is, just to use random resized crop and then aug transforms, which means it's going to augment the image one by one in each iteration, and then in each image it's going to randomly resizing cropping. So it's not like squish or padding or normal. What it does is it's take an image and then randomly resize and then crop. So that's what it's going to do. Cool. I think these are the things covered in data augmentations and about model improvements like resize and different techniques. Then once this is done, we can train the model. So we used ResNet 18 to keep it simple because it's a very simple data set. So after a few epoch, we are getting like close to, I think, 100% accurate, so no error. So that's good. Now what we are going to do is we are going to interpret the results. So Fastai provides a class, classification interpretation. You can use this class, and then in this class you can use from learner and you can pass the learner. So this learner knows the validation datasets and it also knows the model, because learner combines data loaders and their model, and also it knows the metrics. Then we are plotting confusion matrix. So this confusion matrix tells how well our model perform. Ideally you have to get high number in the diagonal, which means this is actual and this is predicted, and you can see bird here also predicted bird. And let's interpret this quarter. If you see this one, we are getting 39, which means out of 39 images like original bird, we are predicting all correct, 39. So there is no misclassification here. Okay, the misclassification is 0. And for forest, out of 37 forest, we predicted all correct, all 37. So this is how you interpret the classification confusion matrix. Another important thing is to find the accuracy from confusion matrix, you just count the sum the diagonal and then divided by all the quadrants. In this case we know the accuracy should be 100, but let's calculate 39 plus 37 diagonal divided by sum of all quadrants, which is 39 plus 0 plus 0 plus 37. You'll get 100. Okay, cool. And there are a few things like precision, recall, and F1 score. Those are the important metrics to interpret the model. We will see in the next sessions, in the upcoming sessions. Another important function here is plot top losses. So far we have seen plot confusion matrix. Now let's talk about plot top losses. So this is what is original. You can see the prediction and what is actual, and you can see the loss. The third number is loss, and the fourth is probability. Okay, so here the loss is log softmax. So we will be learning all the understanding about the all different losses, but for now let's keep it simple. For now we just focus on how to interpret the probability. So 84 means we are 84% sure this image is forest, which is good, but still there is some loss, right? So that's why these losses are arranged in descending order. Like highest is here, and you can see the lowest is here. In our case, our problem is very simple. It didn't help very much, but in usual cases, you'll see this is very helpful. You can see all the misclassifications, and you'll get a lot of ideas on how to improve your model by seeing these, how well the model performing in the datasets and checking their losses. So those are the two techniques covered in model results. Now let's go to data cleaning. So normally what we do is, in this case, if I'm starting this project, what I usually do is maybe I go through all the images, like plotting all the sizes of the image, like width and height. And if some width and height is too big, then I may remove that or reconsider my options around augmentations. So that's one thing. And then I randomly check a few data sets, like I randomly go through the bird folder, and I randomly go through the forest folder, and I randomly pick a few images and see whether the downloaded images are in good shape or not. So that's what I usually do. But here the approach is very different. We build a model first, then use tools like this, like ImageClassifierCleaner, to clean the data. For example, what we are doing is we are just loading ImageClassifierCleaner. This is a class from Fastai, and you are passing the learner. Then it will, you can see this user interface. Here you can see bird or forest. There are only two options, and here you will see valid and train. So there are two options, and this is arranged based on top losses. Okay, so let's talk with bird, and let's go through training. And this is training image. Our model, it's overall it performed very well, but here still the loss is a little bit high. If you see this image, it's not super clear, so that could be one reason. And this is bird. All the images are a bird. So here most of the area is hand. This looks good. And let's go to maybe forest. I think all the images are good. Let's go to bird and validation. So training. Okay, this is a little bit different. And okay, let's say I don't want this image. What I can do is I can delete. Or let's say you want to change this image to maybe forest. 1 second. Okay, so let's say you want to change this image to forest. You can change this to forest, and then you can run these things like cleaner.delete and cleaner.change. So what it's doing is, whenever you choose delete, we will delete those images, and whenever you choose change, we will move the files to corresponding correct folders. Okay, this is how you clean when dealing with image classification models. So those are the things covered in data cleaning. So now let's talk about model deployment. Before that, let me just quickly go through some of the end-to-end steps. So in any machine learning model, the first step is you collect dataset. So once the dataset is ready, you do basic checking and cleaning. Then what you do is you set data validation strategies. Also, after collecting data, you'll be very sure like what's your input and output. Then you do modeling. Then in modeling, what you usually do is you try like different architectures. It's currently writing. Yeah. So after trying different architectures, what you do is you choose one or two architecture and do hyperparameter tuning. So hyperparameter tuning means you will explore different model parameters. In our case, maybe you will play with different augmentation strategies and different resizing, those kind of things. You'll play with all these things. Okay. So model, this hyperparameter tuning is very specific to the model. So it's model specific. Then you choose the best model. Okay, best model, you choose the best model based on validation data. Then you export. And if you're academic, what you do is, let's say you have a test data set. You just pass all the batch of test data set to the model, and then you will report your metrics and other details to the paper. So that's for different. And for normally what we do is we export. After export, we may build a quick prototype. So that you can share it with your team, and it's good for getting quick understanding about the overall quality of the model. So that's very important. Then you deploy. Sometimes after deploy, you also do some monitoring. So monitoring means how well the model is performing in different scenarios. Also, you will check if there is any drift in the data. Maybe after a few months, all the birds are changed to very different, like different area, those kind of things. So those images are very different to what you usually have in the model training phase. Okay, so these are the steps we usually follow. Now, so far what we have done is we collected data set, we did some data cleaning. Our cross-validation strategy is like 80-20, 80% for training, 20% for testing. Then we experimented different models. So we didn't do a lot of hyperparameter tuning, but we can do that. Then let's say we choose the best model. Let's say this is the best model. This is already best. We are getting close to 100%. Now we can export the model. Learn.export. So this export model, if you do that, it will generate a pickle file. So those pickle file knows all the details about how to make predictions. It can do that. So once you run this, you can see export.pickle. Okay, this is a pickle file. This file has all the details about your model. Okay, it's around 44 MB. Okay, now we know how to make predictions with this. So the next step is we need to know what are the labels in the model. To create user interface, we need to know what will be the input image and what are the output. Maybe let's talk about that. So let's say I'm building some user interface. What I usually do is I generate upload file uploader. So if you click that, you can upload some image. Then you can make a button predict. once someone clicks this, you can see the output like 90% bird, 10% forest, like that. So usually this will be the simple user interface. So to know what will be the output, we need to know what is bird. I mean, what model usually have is it has like 0 or 1. In a deep learning model, you have an input image, then you will have many different layers. Finally, you are going to predict 2 numbers, one for bird probability and forest probability. So we need to know which is bird, like first one or second one. We need to know that. So those information is stored in learn.dls.vocab, and you can see it here. It's bird and forest. Okay. Now the second thing is we need to write a predict function. Okay. So model export and write predict function. So here what we are doing is our predict function going to take some input image, and then it's going to make some prediction. Then what if you see this, these predictions are tensors, like NumPy, or it should be tensors, but Gradio app does not support tensors, so that we need to convert this to just a dictionary floating data point. Then once that's done, you are good to go. So we have written the predict function. Now the next step is we can create an app. So if you see this, there are many ways to create an app. One could be like Streamlit, and another is Gradio. But for this session, we'll be talking with Gradio, because in Jeremy's session, he used Gradio to do the deployments. But after this session, I will be providing like 2 videos. One covers with Streamlit, and other covers with normal API, like any Bootstrap or HTML pages. You can create an API, and then you can use those API as a JavaScript function to call some things, and you will get some values. So we can do that. Okay, so for now, let's focus on Gradio. The Gradio has 2 components. One is image components and label components. It has so many components, but for our predictions, we need 2 things. Okay, so if we see our plan, we need to know what is input and output. Our input is image and output is label. Okay, so for that we need to use these 2 components. From Gradio.components, you can import image and label, and you can create an interface. Then it knows what function to use. It will get some input. Our input is image, and then it passes the input to this predict function, and you will get some output. In our case, number of classes is 2. One is bird and other is forest. Okay, then you can launch it. So I think in one of our previous session, we did similar things, and we have seen some user interface within Jupyter Notebook, but for some reason I couldn't see it here. Maybe I need to rerun, but I'll do that. So in the last session, I usually had a user interface here. I think it could be some issue with Gradio, because when I click this, even here, it's not showing me anything. But I'll show you everything in local. Cool. Okay. So far we have written everything in Jupyter Notebook. And by the way, recently Jeremy introduced a new library, nbdev 2. I'll show you that. So this is like create delightful software with Jupyter Notebooks. So within Jupyter Notebooks, you develop so many things, and you can create a publish a blog post, and you can put that as a package in pip, conta, and git. So it supports so many things. With nbdev, we can easily convert Jupyter Notebook to Python scripts. But for now, what I'm going to do is, since our code is very small, I'm going to just copy paste and create in everything in VS Code. But in the upcoming sessions, I'll be do a walkthrough with this nbdev 2, because he introduced like just 2 days ago. So lots of new changes. We can learn it together. So for now, I'm going to copy paste our important things as a file. So what I'm going to show you what are the things I have done. Maybe we can follow step by step. Okay, so far what we have done here is we have completed the model export, and then we created a small components in Jupyter Notebook. It has image and label. Now what we are going to do is we are going to share this in HuggingFace. Okay, so let's do that. Okay, if you go to HuggingFace, you can see spaces. Click spaces and create new space. You can use any name like bird class. Then you can choose license. I'm choosing Apache 2. Then you can see whether you want Streamlit app or Gradio app. I'm choosing Gradio, and you can make it public or private. Then create space. Okay, so once it's created, you can see what are the things we need to do. One is git clone this repo. Then we need to add an app.py file, and then we can push. Then we can see the results in HuggingFace spaces. Also, if we have any lot of dependencies, we can put all our dependencies in requirement.txt. I think that's all. If you do that, you can see your app here. Also, another great blog post is this one. So this is from one of the Fastai community member, Tanish. So he has written about model deployment with Gradio and HuggingFace spaces. I think it's a great blog post to follow. Okay. I'll share this on our Slack. Also, I'll share this notebook. So this is the same Jupyter notebook in Collab, so that I can share it with everyone. Copy link, done. Okay. So we need to follow these steps. We need to create app.py and requirements.txt. And also, if our file is huge, we need to use git lfs. Maybe I'll go through the steps in my writings. So first step is HuggingFace space. If the file is big, you need to use git lfs, and you can create space on HuggingFace, what we have done just recently. Then we add everything to our space. Then we push to our space. That's all. So let's do that. Okay, if you see my code, I have created app.py. Then I have created requirements.txt. We just need Fastai, and then in the app.py, I have this is our model. We exported our model, and we can load our model using load learner function. Then we already know what are the labels by going through learn.dls.vocab. Then these are the functions we have already written on Jupyter Notebook, the same function. So if you see this one, our input is image and output is label, and we can write some descriptions, title, and we can also provide some examples. So instead of user uploading the image and then make some prediction, what we can do is we can just provide some examples, and then we can click that example file so that we can make some predictions. And we can also do some model interpretation there. It's pretty helpful. So to run this, you can use just Python 3 app.py, and you can see it here. It's currently in my local. I'll show you. Should be this one. Okay. So this is the bird or not classifier. So you can choose any image, and you can submit, and you can see the output. So this is bird 100%, and let's choose forest. Submit forest. Also you can interpret. If you click interpret, it will tell you where it's looking most to make some predictions. You can see it here. So most of the area comes from here, branch, and this area. We'll see all those things in our upcoming sessions. Cool. I'll show you the other important thing is before pushing everything to HuggingFace space, if you see our export.pickle file, it's a huge, like around close to 50 MB. For that, we need to use git lfs, git log file. So let me show it here. So basically, you can just copy these things, git lfs install, and he also provides how to install git lfs if you are Mac, or you can use Brew, and Windows you can follow this link, and for Ubuntu apt-get install git lfs. So you can follow git lfs, and then you can push everything to HuggingFace spaces. Another way to do that is, instead of using git lfs, I think you can go to files, you can add file, and you can upload file. You can also do that. So currently in my case, it lfs. So this is another classifier, comes from a community member. I think this is interesting. So this is not like 100% sure because it's a mix of both cat and dog. Let's choose this one. Cat, dog. So another thing is, once you have some app here, the great thing is, maybe before introducing that, let's talk about this one. So far we have completed these things, HuggingFace spaces, and we know how to handle big file. Then let's talk about API. So what we have done so far is we built a model, and then we deployed everything on HuggingFace spaces, or we built Gradio app, or we can build Streamlit app. But what if you want to generate some fully controlled, like complicated web app, something like that? What we can do is we can push everything to HuggingFace spaces. Then you can see this view, the API. So here it will provide some JavaScript API. With that, we can directly make some predictions. You can see it here. So this is the API, and you can pass some JSON data, and we can make some predictions. And using JavaScript, you can see the URL, and you can see some image, and you will get some response. So this is very helpful because we no need to depend just on Streamlit or Gradio. With this, we can build some complete, controlled, powerful web apps. Maybe in the upcoming sessions, we will do a quick demo on that, like using a Bootstrap. We can create a web app, and then we can make some predictions using this HuggingFace API endpoints. So this is very helpful. Cool. I think with this, I'm going to end our session now. I think so far we have covered about different techniques about model, like resize, squish, pad, crop. And for augmentations, we covered random resize, crop, and different augmentations. Then for model results, we learned about plot confusion matrix. We learned how to interpret the confusion matrix. And also another important function is plot top losses. So that's all for model results. And for data cleaning, we used ImageClassifierCleaner, and then we can, it's like a user interface. In that user interface, you can provide like delete or change. We have seen that. So once that is done, you can save, and then it will delete or change so that you can retrain your model. Then for model deployment, we exported all the files. Then we have written some predict functions. Then we have built some Gradio app. Then we shared everything on HuggingFace spaces. We also learned how to handle big files. And for API, we know how to access the API. With that, we can create some HTML pages in the upcoming sessions. I think that's all.